Type N Thermocouple, the advanced temperature sensor. Hello friends. Welcome back to Yog Thermal Guru. In today's video, we are diving deep into the N Type Thermocouple, a modern thermocouple designed to overcome the limitations of older types like K and J. By the end of this video, you'll know its construction, temperature range, accuracy, pros, cons, and where it is used in real life. Let's begin. Background and development. Type N Thermocouple was developed in the 1970s by Dr. Noel A. Burley in Australia. His main goal was to solve the problems of K Type thermocouples, which suffered from drift, instability, and oxidation at high temperatures. The result was the Nicrosil Nisil thermocouple, which is why we call it Type N. This thermocouple quickly became popular in industries that needed high accuracy and long-term stability. Construction and working. Like all thermocouples, the N type works on the Seebeck effect. When two dissimilar metals are joined, they generate a small voltage depending on the temperature difference. The positive leg is nicrosil, nickel, chromium, and silicon. The negative leg is nisil, nickel, silicon, and magnesium. This special composition prevents problems like green rot, which affects K-type thermocouples at high temps in low oxygen environments. Drift due to nuclear radiation. N-type performs better in reactors. Oxidation of alloys, nicrosil, and nisil resist scaling and degradation better than common alloys. Temperature range and sensitivity. The N-type thermocouple works across a wide temperature range, 200 degrees C to plus 1300 degrees Celsius in general use. In special cases, even up to plus 1400 degrees Celsius. The sensitivity is around 39 V per degree C, slightly less than K-type, which has tilde 41 V degree C. This means it produces a little less voltage for the same temperature rise, but the trade-off is better accuracy and stability over time. In terms of tolerance, standard limits, plus or minus 2.2 degrees C or plus or minus 0.75%. Special limits, plus or minus 1.1 degrees C or plus or minus 0.4%. So, in long-term operations, Type N performs more consistently than K-type. Advantages. Why should we choose N-type over other thermocouples? Here are the key advantages: high stability, less drift in calibration even after long usage. Resistant to high temperature oxidation, thanks to chromium and silicon. Does not suffer green rot unlike K-type. Performs well in nuclear radiation environments, making it ideal for reactors. Wide usable range, cryogenic, minus 200 degrees Celsius, to extreme heat, plus 1300 degrees Celsius. Longer lifespan, saves cost in critical industries. In short, N-type is designed for reliability and accuracy in harsh conditions. Disadvantages. Of course, every sensor has some drawbacks, higher cost than K or J-type thermocouples. Lower sensitivity compared to K-type, meaning slightly weaker voltage signal. Not as common, fewer suppliers, and less availability in the market. Requires careful calibration when used in precision measurements. So, while it's technically better, budget-sensitive applications may still prefer K-type thermocouples. Applications with examples. Where do we actually use N-type thermocouples? Let's see some examples. Aerospace industry, for jet engine exhaust gas temperature monitoring. Power plants, steam turbines, and nuclear reactors. Metallurgy and foundries, measuring molten metal and furnace temperatures. Oil and gas industry, high-temperature refining processes. Scientific research labs, long-term stable measurements under extreme conditions. For example, in a steel plant furnace, where temperatures reach above 1200 degrees Celsius for long hours, an N-type thermocouple will give stable readings without drifting, unlike a K-type which may degrade over time. Comparison with K-type now. Let's compare N-type versus K-type thermocouple since they are often seen as competitors. Temperature range almost same, but N-type is more stable. Cost: K-type is cheaper. Accuracy and drift: N-type wins with better stability. Availability: K-type is widely available everywhere. Suitability: for critical industries, N-type is better. For general use, K-type is more economical. Thermocouple look like this in real. So friends, that was the complete breakdown of the N-type thermocouple. To summarize, it's a modern, stable, and reliable sensor, specially designed to overcome the weaknesses of the K-type. It's more expensive, but when accuracy and long-term stability matter, N-type is the better choice. If you learned something new today, don't forget to like, share, and subscribe to Yog Thermal Guru. Stay tuned, because in our next video, we'll explore more about thermocouples and temperature measurement in detail. Thanks for watching.